We start to learn the last subtopic of the How dimension in terms of the independent inventory management, the reorder point. So we have already discussed the ABC analysis, which help manager to identify the most important inventories. And we also discussed the EOQ and the three common matrix. The EOQ helps manager to decide the quantity, how much inventory they should order, and the three common matrix give the manager the idea about how the inventory management is. In this video, we start to discuss the reorder point. It talks about the time. So when should the manager place an order? So this is the reorder point. The reorder point is the point you should place an order to meet the demand, because we know that the inventories have been spent constantly. So every day you need the inventories to meet the demand. So the reorder point is the point you need to place an order that all of the inventories you have can meet the demand. Why we need that? Because in reality, if we back to the EOQ, one of the assumption is like you can receive the order immediately once you place an order. But in reality, you have to wait. Whatever it's 2 hours or 2 days or 2 months, you have to wait to receive the units you ordered. So this is what we have. Because of the lead time, we need to consider to place an order before the inventory is equal to 0. So this is what we have. If we think about a very simple situation, just like the EOQ analysis we have analyzed, if the demand is constant, which means every day you need the exactly same units. So if you need 2 units today, you need 2 units tomorrow, and you need 2 units the day after tomorrow. So if you know the lead time and the average daily demand, you will have the idea about the reorder point. So the reorder point equal to the lead time times the average of daily demand. So just like the examples I gave to you, if every day it needs 2 units, and what if we know the lead time is 3 days? So we will have an idea. During these 3 days, the total units you need to meet the demand is 2 times 3, it's 6 units. So the 6 units here are the total units you should keep to meet the demand during the lead time, during the 3 days. So you will have an idea whenever your inventory reduced to 6 units, you need to place an order to avoid experience the stock outs. So whenever you have 6 orders, 6 units, you need to place another order. So this is what we call the order point. If the demand is constant, we use the lead time times the average daily demand. You will have the numbers. You will have the conclusions about when you should place an order. But the reality is, in general, the demand is not constant. We may need 2 units today and may need 5 units tomorrow and 10 units the day after tomorrow. So the demand is always change. And also the lead time is not fixed. So for this order, you may need 3 days. For another order, you may need 4 days for the same orders. So this is the differences. This is in the real business world. If we consider more complexity of the situation, the demand is not constant, it's always change, and the lead time, the time you expect to receive the orders, is also changeable. So for that situation, except for the general idea, like except for the units I just calculated over there, like equal to the lead time times the average daily demand. In general, we have some units we need to keep, some units we present the safety stock. So you need to keep a safety stock on hand to meet the demand. Then we will have a questions. How much safety stock should you hold to meet the situation, like the demand is not constant, the lead time is not fixed? How much of the safety stock you should keep? If you want to answer these questions, how much safety stock, you need to consider two things. The first one, your service level policy. So at what level you want to meet the demand? You want to have a 95% accurate to meet the demand, or just 70% is acceptable to meet the demand in terms of the possibilities? So you need to establish the service level policy of your business. And the second questions you need to consider is to determine the level of the demand variability during the lead time. So this is the two things you need to consider about when you want to decide how much safety stock you should hold. So let's take a look with the probability, the service level. Actually, the service level depends on the industries your business in. For airline companies, for the grocery stores, they are the total different stories. So you need to consider about your business strategy, the industry standards, the competitive strategy, the customer expectations, and others to decide the service level. This picture here shows a standard normal distribution here. And if you set your order points equal to your expected demand during the lead time, so you don't consider the safety stock, you will have a 50% chance to meet the customer demand, because if we take a look with the normal standard distribution, so if you meet the lead time demand, you will have a 50% to 50% possibilities to meet the demand. So how much probabilities you want to have? Just as I have mentioned, it depends on the strategies, depends on the customer expectations and others. And in general, if the stock out costs are low, then a 90% cycle service level is acceptable. So which means you have 10% stock out risks if you take up this the order point here. And now we need to think about, if we want to achieve 90%, how do we calculate the safety stock to achieve that cycle service level? So the first thing you need to figure out is about the Z-score. This is not unfamiliar things, right? Actually, when we learn the control charts, we have the 3 standard deviation, we have 6 standard deviation, 2 Six Sigma standard deviation. We mentioned the Z. So this is the Z-score. You don't need to calculate the Z-score. You can obtain the Z-score for the tables, or you can search online. So it's just like depends on what kind of cycle service level you want to keep, and you will have the z-score for the standard deviations here. If you want to have 90%, the z equal to 1.28, and if you want to have a 95, this is the values for z. So this is the first step. When you want to know what is the safety stock you should keep according to the service level, the cycle service level you want to achieve, the first step is to find the z value. Once you decide z, then another thing you need to calculate is what we call standard deviation of demand during lead time. So you need to know these numbers, the sigma DLT. So this is the sigma is the standard deviation. D means demand, LT means the lead time. So the standard deviation of demand during lead time. So this is another thing you need to know for the safety stock, how much safety stock you should hold. And if you want to calculate this one, the sigma DLT, you need to know the following four numbers: the average lead time, the standard deviation of demand, the standard deviation of lead time, and the average demand. So actually they talks about the two things: the demand and the lead time. So for demand and the lead time, you need to know two things: the average number and the standard deviation. So you need to know the average demand and the standard deviation of demand. You also need to know the average lead time and the standard deviation of lead time. So after you obtain these four numbers here, you will be able to find the standard deviation of demand during lead time, so the sigma DLT. And let's take a look with the example here. So imagine that your average daily demand is 12 units per day. So this is the average demand we already have. And you look at the data and know that on a snow day, the demand is only 5 units. On a busy day, the demand is 18 units. And you can calculate the standard deviation of the demand to be 1.7 units per day. And you considering the lead times, so you have the average lead time is 8 days. And it has a range for 3 days to 15 days and have a standard deviation of the 2.3 days. So according to the information, we already have the average demand, we already have the standard deviation of demand, we have the average lead time, and we have the standard deviation of lead time. So we will be able to calculate the sigma DLT, the standard deviation of demand during lead time. So we use the average lead times times the standard deviation of the demand square and plus the average demand times the standard deviation of the lead time. So we have an idea about the sigma DLT is 28.02 units. So this is the sigma DLT. Then what is the safety stock you should keep on hand? It depends on the service level you have. So if the service level here is 90%, then the z equals 1.22. If it is 95%, the z equals 1.65 and until others. Then what is the safety stock you should keep on hand? The safety stock equal to z times sigma DLT. So according to the former information, you already have the result for sigma DLT. So it depends on what kind of service level you want to keep. Then you will have an idea about how much you should keep for the safety stock. And this formula here is for the reorder point. It equals to the average demand times the LT. So this is the demand during the lead time. The demand during the lead time here, it equals to the average demand times the LT. So this is what we have already introduced at the beginning of this videos. So if the demand is constant and the lead time is fixed, we will have an idea about what is the reorder point here. So if we know the lead time, if we know the average daily demand, we will have the 6 units. This is the what we call the demand during lead time. So this is what we have. And the reorder point is just like we use the general idea, the average number, the average demand during the lead time plus the safety stock. So this is the reorder point when the demand is not constant and the lead time is not fixed. So back to these specific problems. So if we know the average demand is 12 per day and the average lead time is 8 days, so we will have an idea like during lead time the demand will be 12 times 8 equal to 96. So we should have 96, and because we want to provide a service level with 95%, so we have Z equal to 1.645, and 28 is what we have obtained for the sigma DLT. This is the standard deviation during the demand during the lead time. So we just plus the safety stock. This portion is the safety stock. We just plus the safety stock. This is the order point you should have. Compare with 96, we need to place an order when the demand reduced to 143. So this is the reorder point examples, the reorder point calculation process about when you should place another orders. So if you have a very clear idea about the demand and about the lead time and they are not change, they don't change, then you can just use the DLT as the reorder point. But because of the reality business world, we need to keep some safety stock, and this is how we calculate the safety stock. So we need to keep more. So compared with 96, actually when the demand reduced to 143, you need to start to place another order in case you meet any risks. So this is about the reorder point. If we combine the example together, if we think back to the EOQ stuff, this is the total cost when you place the orders with 404, and this is what we have for the safety stock, the 47. So we just back here. The 47 is what we obtain for the safety stock. So this is the safety stock, and per unit we need $6. So this is the total cost for holding those inventories. Except for the orders you placed, you also need to consider, if you have any safety stock here, you need to consider the holding cost for the safety stock. So this is how we calculate the inventory management considering the reorder point.